every time you see a square root of -1, or anytime you see a square root of a number, you can extract out an I, or an I is represented by a square root of a negative number. The only thing new and the only power of I that we will focusing in for our item is every time you see I square. Whenever you see I square, we can substitute the I square to become a -1. So that's the only two things that we will be using in our complex number for this chapter for us, okay? When you go to the next one, when you go to 130, there is a different power of I, but when we go up there, we will mention that. But for now, the only two power of I, which is I to the first power, which is simply just I, is equal to a square root of a -1. And if you see I square, you can translate to -1. That's all for us that we will be doing. And we did this problem yesterday. As I mentioned, how do we multiply? And this is the only last item that we have in our chapter 10, is how do we multiply complex number? We don't have division. It's really not division, it's basically rationalize the denominator. But for us, how do we multiply this? And just like before, whenever we try to multiply a binomial, whenever we try to multiply a binomial, all we need to do is distributive your item. We do a FOIL, first time first, outside time outside, inside time inside, last time last. And this is what we have. If we take 4 times 7, we should see that that is equal to 28. 4 times 11i to give you 44i. 3i times 7 to give you 21i. And 3 times 11 to give you 33. I times I square. Remember, 1i and 1i. If you have I times I, all you do is you add the exponent. The 1 plus 1 will give you I square. So this is what we need to do, is once you distributive them in, this the only thing new is you need to combine like term, and you need to convert that I square that I just mentioned, that every time you see an I square, you need to convert that or substitute that to become a -1. So once you substitute a -1, this is our new problem. I combine like term right here. The reason why I have a 65, the reason why I have a 65i is 44 plus 21. That's where my 65i came in. And once I substitute the -1 for the I square, once I substitute -1 times 33 to give me a negative 33. And that's where we have our like term because of this number, because the constant is 28 and a constant of -33, we can convert this in terms of 28 take away 33, that will give you a -5. So that's the only thing new in terms of FOIL this item out, is we need to substitute an I square to become a -1 because that's our property of I. And then we combine like term. So we did this last time, and this is where we stop. And I mentioned about this B portion is similarly, right? If we have 9 minus 2i multiplied to 3 plus 7i, if you were to have this problem, just like before, nothing new, all we need to do is we need to distributive this item in, right? We need to take the 9 times 3 to give you 27, the 9 times 7i to give you 63i. And then you take a -2 times 3 to give you -6, or -2i times 3 to give you -6i, a -2i times 7i, a negative times a positive, you give you a -14, I times I to give you I square. So again, if I multiply the 9 in, and then I multiply the 2i in, this is what I have. This is what I should have, is 27 plus 63i minus 6i minus 14i square. What do I need to do? The only thing you guys need to do is you need to combine like term. In this case, your I and I is your like term. And on top of that, because of there's an I square, we need to convert that to become a -1. So we have 63 take away 6 to give you 57i. -14 times a -1, because the I square become a -1. -14 times -1 become a positive 14. And what do? We need to combine like term. The leftover we have is 27. The leftover that we have is 27 added to 14. And if 27 added to 14, you have 41. And whoever say, yes, this is what we have, ladies and gentlemen, if you recognize that all you're doing is this, if you have not recognized it, if you recognize that all we're doing is, if you have an I square, everybody see that the only thing we're doing is we changing the sign in front of that number, right? Basically, again, -14 I square, because of the -14 I square, we change it to a positive 14. And that's technically, that's what we're doing. Positive 33 I square, we change it to become a -33. Okay. So again, in our problem, or in our FOIL or multiply this complex number, that's the only two new item is the I square. You change in the sign of the constant in front of it because you multiply by a -1. Okay. So let's try one more before we do other problem. What if, right? What if we have something like this? And again, if you have something like this, if you remember your special product, we take the first item square, multiply the two items, double them, and then we take the last item square. If you remember that product, if you remember that rule, you can go ahead and do that item is the same. If you don't remember, it's okay, because now, do you agree that 5 minus 9 square is the same as 5 minus 9i times 5 minus 9i? And if you were to able to break it down like this, then the only thing we can do, or the only thing we need to do, is we need to distribute the 5 in, and then we need to distribute the -9i in, right? That's what we do, is we take the first item, we multiply to the second item, and in this case, this is what I have. 5 times 5 is 25. 5 times -9 to give you -45i, and then the -9 times 5 to give me -45i, and a negative times a negative will give me a positive 81. But even though we say a positive 81, because of the I square, that 81 should be, need to change it to become a negative. So combined like term, I have 45, 45 to give me 90. Keep the sign of the negative. And again, -1 times 81 to give you -81. And then you combine like term, everybody see that this is what we should have. 25 take away 81 to give you a -56. And again, the last thing I mentioned yesterday is, if you have a constant, no matter what the constant is, if you have a constant, you want to put the constant first, because this is the real portion of the complex number. And if you have an I, you want to put the I in the back. Okay. So looking at this item here, question with this here, ladies and gentlemen. Any question of this particular problem? So if you don't have question, let's take a look at this item. Let's continue. Let's do this item. If you were to see this, right? If you were to see this on your regular problem, how would you guys do it from scratch, right? So let's say, again, same thing go. Let's say simplify. Let's say we want to simplify this item here. And let's say A. And let's try 3 plus 4i squared, right? So for instance, let's say that this is our problem and we have 3 plus 4i squared. How would we go? How would you guys go to attack this problem? Well, there are a few ways. And again, one way is we can say 3 plus 4i times 3 plus 4i. And this is one way probably a lot of you guys will probably consider, because if you don't remember, take the first term square, multiply the two and double them, and take the last term square. This is what we do, right? And again, let's do this, what we have, or how would we go about to do this? And let me use my color coding. Again, do you agree that this is what we do, is we take the first item. And again, the first item, the 3 times the 3, everybody see that 3 times 3, that will give me 9. And we take the first item, the same, 3 times 4. Do you agree that 3 times 4 to give me 12? I bring down my I. So that's where we have, in terms of the first two number, that's where we have is the first item distributed to the second parenthesis. And the second item, we do the same thing. We take the second item and we distributive into that. 4i times 3, 4 times 3 to give me 12i. And 4 times 4 is 16, and I times I is I squared. And again, everybody see, again, this is where my 4 number come in. Question on how I have this 4 number here. Because now the only thing left that we need to do is we need to combine like term here. And because of this I, right, if we do it, no, for you guys, this is probably what you guys did, is you got basically add this two number, 12 plus 12 is 24, kept the I. And all we do, and simply, this is all we do, guys. Because it's a positive here, you need to change it to a negative, because technically this is 16 times a negative 1. 16 times a negative 1 to give you a negative 16. That's technically, that's all you're doing, is you're changing the sign. And that's what I mentioned earlier, is all we're doing is we're changing the sign. And once you change in the sign, you can see that this is your like term. What is 9 take away 16? Well, 9 take away 16, do you agree that a smaller number take away a bigger number? You still have a negative, and in this case, you have a negative 7 plus the 24i. And that is your answer. That is the answer, or that is what you simplify to that problem there. Okay, so looking at this thing here, question with A. Question of how do we multiply, how do we simplify this complex number? And again, same thing go, let's try B. Let's try B, and let's say if we have 11 minus 3i times 2 plus 7i. And again, after this, hopefully you guys see that this is very, even though the number is different, right? Even though the number is different, but we are able to, using what we've been doing, which is we've been using distributive. We can take this 11 and distributive to this item, 11 and distribute to that item. And if we take 11 times 2, we know that 11 times 2 to give me 22. 11 times 7i to give me 11 times 7 is 77. I bring down my I. Everybody see where I got the 22 and the 77i. And I do the same thing with this negative 3i. Negative 3i times that to give me a negative 6i. A negative times a positive to give me a negative. 3 times 7 is 21. I times I to give me I square. Reminder, the only time you increase the power is when you multiply, okay? When you add or subtract, you only add or subtract the coefficient and you kept the variable. You do not subtract them, the exponent, right? So if you do this thing here, we can see that this is the two items we 22, 6 to give me positive 71, bring down the I. And this item here, because of the I square, is convert the 21, a negative 21 to become a positive 21. And like I mentioned to you guys, that every time you see I square, you need to substitute that with the negative 1. Negative times a negative become a positive. That's why I have a positive 21 here. Now, to finish this thing up, we know that this is my like term, a 22 added to 21, for I have 43 plus 71I. And to simplify, that is my answer. Question here, ladies and gentlemen. And again, even though it say complex, there's nothing complex about this item, right? We do it the same way as we did it before. So question would be here. Now, let's take a look at C. And again, if we were to ask you something like this, 13 minus 17I subtract 2 plus 3I. So be careful, right? This is what you need to ask yourself is, what operation do I have, right? What operation do I have for this particular problem? And hopefully you guys see that up here. If I erase all this mess that I create, erase all this color-coded mess, that we don't have any operation in between the two parentheses. And if we don't have any operation between the two parentheses, well, the two parentheses without the operation is just assumed to be a multiplication. And that's what you need to be careful is, if there is an operation, and in this case, there is an operation, and this operation is a subtraction, right? This operation is a subtraction. Make sure that you do not distributive, you do not multiply, but when you subtract, basically we combine like term. And to combine like term, reminder, to combine like term, we need to get rid of the parenthesis. And in order for us to get rid of the parenthesis, we need to change the sign. We need to change the sign for the second parenthesis, right? So again, the first parenthesis, there everything is the same, but the second parenthesis, I need to change this to a -2, and I need to change this to a -3i. So basically, we take this -1 and we distribute it in. Because there's a negative, unlike addition, which is the next thing, addition for subtraction, for you to drop the parenthesis, you need to change the sign of this parenthesis here. Because it's positive, it's become a negative. Because it's a positive, become a negative. Once you change the sign, once you distribute the negative in, this is all we're doing is by like term. If you have 13, take away 2, clearly or easy enough, 13 take away 2 to give you 11. If you have a negative 17i and a negative 3i, both of them are negative. So I need to add and keep the sign. So the sign will be negative. 3 plus 17 to give me 20, and I have an I. So this is my answer for this simplification, or simplify this item here, okay? So again, in order for you to add, and you need to make sure that you see that your operation is addition or your operation is subtraction in, right? If we have something like this, right? Make sure that you see that, hey, this is my addition, right? This is my need to add up my subtraction. I need to subtract. And up here, if there's no operation, it's meaning multiplication. So those are your three operations deal with complex number. Don't, it's weird. It's weird that when we do this, if I were to give you guys the test on paper, somehow most of my students, when they see that, oh, the first parenthesis, oh, the second parenthesis, what they do is they go in and they distribute, they go in and they multiply. Operation, and you perform that operation is not that you always multiply. Okay, so again, to add, how easy is this? All you do is you drop the parenthesis, because it's addition, it doesn't matter. We just drop the parenthesis and we combine like term. My like term is I have a negative 19 and a 5. Because I need to subtract and keep the sign. So the bigger the number, which is negative 19, so I have to keep the sign of the bigger number, which is negative. Take away 5, I still have 14. Same thing go if my like term, I have a negative 21i and a positive 11i. Because they are different sign, I need to subtract and keep the sign of the larger. In this case, the larger number is negative 20. The not larger number is negative, is 21. The value is small, which is negative, right? And again, because it's 21 is bigger than 11, I need to keep the sign of the 21. In this case, I have a negative 21. So again, my answer is negative 14, take away 10i, and 14 is a real portion and the I is the imaginary portion. So this is your answer. So as complex number, but it's very doable. It's basically combine like term, right? When they ask you to add, you just basically drop the parenthesis and combine like term. For subtract, a little bit different. For subtract, in order for you to combine like term, you need to change its second parenthesis, and only the parenthesis after the minus sign. The parenthesis in front of the minus sign, anything, we just do item inside or the second parenthesis after the negative. And if they ask you to multiply, then you distribute, you take this item and you distributive in, you take this item, you distributive in. And same thing go, you distributive the negative 3i. And if you have something like this, then all you need and this. So question with the first 4 problem here, ladies and gentlemen. Nothing new. Well, I is new, but not about complex number, right? How ironic. Now, the other problem, let's move our way backward, right? The other problem, they ask you something, go simplify. And what if they ask you simplify and they say write solution a term of I. Meaning, let's say that E, they give you this item here, a square root of a negative 90. This brings us back to chapter or in the previous section, right? We know that 98 is not square. That's what we know, right? Because why? Because we know that 81 is a perfect square. 80 is a perfect square, is 9. And we know 100 is a perfect square, which is 10 times 10. And 89 is somewhere between. 89 is somewhere between 81 and 100. So that will be 9 point something. If you type in your calculator, it's probably 9.9 something, right? It's very close to 10, but basically they ask you to, can you simplify can you simplify by take out a hidden perfect square? Okay, so for me, this is what I do first, ladies and gentlemen. For me, if I see a negative number, and in this case, there's a negative number, if there's a negative number, what can you bring to the outside? That's what you want to ask yourself first. See that I can, and give me this, right? Because of the negative number inside the radical, I can bring I, and if I bring out I, have 98. Now, is there a perfect square in 98? If you don't see it first, don't worry about it, because let's break this thing down, right? For me, if I don't see in the beginning, I don't know what the multiple of 98, I can break it down by 2. I can say 2 going to 98 will give me, what is 2 going to 98? 2 going to 40 to 98 divided by 2 is 49, and we can stop here. Why we can stop here? Is the perfect square. Why? Because do you agree that 49 is the same as 7 times 7? And because it's a perfect square, if not, if you don't see it, we break it down. Neat, I don't care. And the purpose of finding hidden perfect square is because it's a square, we can bring out a 7, we can bring it to the outside. Our answer will be 7i. The leftly or the longly number, the leftover is the 2. So this is our goal, is we need to convert this item. If they give you this item, we need to convert to that item, which is 98 equal to 7i square root of 2. And I mentioned this yesterday, that if you have an I and a square, they want you to write I font. You don't write it like this, ladies and gentlemen. The reason is sometimes some of you guys probably item and you see that the I is underneath the radical. So that's why they don't advise you to write an I in the back. If you have a radical, they want you to write the I in. So let's try another one. What letter are we at? F. So since they give you some nature, and this brings us back to the previous in term of the unperfect square. Let's do make it small number first. I think you saw this already. Already, but again, let's say square root of -4. So how do we do this square root of this -54? Again, what is a perfect square in here? Well, first of all, hopefully you guys see that we cannot say no solution. No longer we can say no solution, right? Earlier we say, oh, negative number, no solution, but now we cannot. We have to say there is an imaginary answer. And this imaginary answer, what can we do? We can bring our an I side is bring that on the outside. And if you don't see that this is 9 times 6, if this is 9 times 6, do you break this out to become 2 times 27, right? And if I break the 2 times 27, 3 times 9, and probably say, Mr. Tran, I can stop here. Why we can stop here? Because the 9, we found it. The 9 is the perfect square number, right? Because 9 is equal to 3 times 3. So if you guys see that the 9 is a perfect square, what can you bring it to the outside? This 9 is a perfect square, can bring it 3. And there is the leftover. What is my leftover? My leftover is a 2. I have a 2 here. A 3, I have a 3 here. So what is 2 times 3 on the inside? 2 times 3 on the inside, you can see, will give me 3i square root of 6. Because 2 times 3 is 6. So that's why I told you guys that you already, if you guys see that 9 times 6 is 54, and you say, oh, the 9, I can bring it to the outside, do that in the get-go. You can see that. You can do that in the beginning if you want to, or you can break it out by, okay? So question with this particular problem here, ladies and gentlemen, and let's challenge, well, no, I don't want to challenge you that. Let's try this thing here. Let's do one more, and then we do the hard problem. Same thing go. Let's say if I have a square root of a negative 180. If I have negative 180, and this is, again, please do not do this. Do not say 180. We never break it down by, I never did it. I never break it down by addition, right? The only time you can break, the only thing that you break down is you break it down by multiplication. You can break down by 10 times 18. You can break down by 10 times 18, and I accept that, but you cannot break it down 100. As you say, 100, 10 times 10. We never break down by addition. So don't, I don't know why I mentioned to you now something in your head that you break it down. But again, we never break it down by addition. Okay. So looking at this thing here, go with our consistency for make it consistent. Because it's a negative number, I know that I can bring out an I. So worry about this negative. Okay. As long as there's a negative on the inside. If there's a negative on the outside, there's nothing you do, right? If there's a negative on the outside, this thing just a -5, right? Because there's a negative on the inside, we take out an I. Excuse me. What can we break down? If you don't see, and I don't see it, right? I mean, if you don't see that 36 is in here, just break it down by what we know. We know that 2 times 90 will give you 180. And if we know that 2 times 90 to give you 80, we know that 2 times 5 to give you 90. And again, we still a pair of 2 number. We know that the 2 can bring it outside. And then this item, we know that 9 times 5, and 9 is a perfect square. Those are your 2 items that you want to looking for. You either want to looking for a perfect square number, which is 9 because it's 3 times 3, right? Or you want to looking for a pair of 2 of the same, right? So anything that have the line underneath, I don't look at it. So because I have a pair of 2, everybody see that because I have a pair of 2, I can bring 2 on the outside. Because I have a pair of 3, I can bring 3 to the outside. So if I bring a 2 and a 3 to the outside, what is the leftover? Everybody see that the leftover is just a lonely 5 here. Because I bring the 2 out, I bring a 3 out, the only thing left is a. So this is what I square root of 5. And that is your answer, ladies and gentlemen. And again, whoever say, Mr. Tran, I saw this 30, you are good. If you saw the 36 times 5, and why do we use 36? Because 36 is a perfect square. And as you can see, 36 on the inside, what do you bring it to the outside? Well, if 36 is on the inside, all you need to do is bring out 6, okay? So that's the idea of this item. The only thing new, the only is because of this negative number, or because of that negative, we have to put an I in front. We have to put an I here because of that negative. Question here, ladies and gentlemen. Now, let's attack the heart, that we, and again, the hardest problem that you encounter, that you will encounter, is they will ask you to solve. And this is probably the hardest one. Let's say G, and let me put a store. And the reason why I say it's the harder one is probably this is the longest problem that you will see, or let's straight and give you this problem. And again, I don't know that you will see this problem. I don't know if you will see this problem on your material. Subtract, not add. But let's say if we have this item here. So if you were to have this problem, and again, what is the difference between this problem and any of the prior item? Any of the item before, they tell you to simplify, right? Any of the item before, they tell you to simplify, there's no equal sign. Now there is an equal sign, we tell you to solve, and I guess solve and check. So before we solve this thing here, ladies and gentlemen, if you remember what we did last time, or if you remember, this is what we need to ask ourselves. Is my radical, this is what you need to ask yourself, is your radical, is this item isolated? Is this item by itself? And you probably say no. The answer is no, because there is some number lingering with this radical. So because there's some number lingering with this radical, you need to get rid of this number, and to get rid of this number, you need to add. And if you add them, this is your new problem. Your new problem is 2x, square root of 2x plus 7 equal x plus 2 is just x plus 2. There is nothing else to it, because the x and the 2 are different terms. We got it, right? We got the root by itself is equal to whatever this item is. We don't, for now, we don't care. We know that my radical is by itself. So now if my radical is by itself, what do I need to do to get rid of the radical? Well, to get rid of the radical, I need to square them up. And if I square on one side, I have to be fair, and I square to the other side. The reason is a square and the square root. The square and the square root, they cancel out. So this is what we have. We have 2x plus 7 on the outside, x plus 2 times x plus 2. The reason is because of this square, we need to write the x plus 2 twice. And the reason why I put the store, and the reason why I say this is hard, because this is to do is to move it to the other side to get your radical by itself. Secondly, you need to FOIL this in. So if you FOIL this, this is what we have, right? We take the x times the x. The x times the x is x squared. The x times the 2, the x times the 2 is 2x. And then if you take the 2 times the x, well, the 2 times the x is 2x, and a 2 times the 2 will give you 4. Combine like term. Combine like term, this is your new item right here. Ladies and gentlemen, your new item is x squared plus 4x plus 4. Everybody see on the right-hand side, that's what I have. I distributive in, and that's what we did earlier with our complex number. If we have another parenthesis, need to distributive them in. There's nothing to do on left, I just bring it down. And after all this thing here, like I mentioned, we are not done, because in order for you the x square, in order for you to solve the x square, we need to factor. And in order for you to factor, we need to set the equation to be equal to 0. That's what we need to do, is we need to set the equation equal to 0. So how do I set the equation equal to 0? As I mentioned to you, move this item over. Do you agree that in order for me to move it over, I need to subtract the 2x? Because 2x minus 2x, they disappear. And I need to put the x in terms of the like term. So let me do that first, right? Let me do both of them. I need to move the item over 2, and to move the 7 over, I need to subtract 7. So as you can see, my new problem, or when I move it over, this is what I have. I have 0, because all of this thing here is equal. It's 0, all this thing here cancel out. X squared, 4 minus 2 to give me 2 left. 4 minus 7 to give me a negative 3. So now we have x squared plus 2x minus 3 equal to 0. What do we need to do? We need to factor. And if you factor this, I would say, factor. Why is easy? Because we break down the x. Is that 2 number? Multiply to give you 3, but subtract to give you 2. Do you agree that 3 is only 3 and the 3 is positive? And looking at this thing here, we are not done, because now we haven't solved it yet, right? The x is not by itself. In order to get x by itself, I take the first parenthesis and set it equal to 0 to give me x plus 3 equal to 0. So I need to minus the 3 to give me x. In item, I have x equal to 1. Question here, ladies and gentlemen. Question here in terms of the step. So after all of this, we are not done. You say, what's going on? Why are we not? The reason is, if you look at this thing here, this is my original problem, right? This is my original problem here. And they give you this item. We got what we have, -3. We have -3 and 1. So this is x is equal to -3, or x is equal to 1. So what you need to do is you need to plug in the x to test your answer. And most of the time, your square root, you have only one answer. So you have to know which one to do, which one you have. If you plug it in, everybody see right here. If you plug it, the -3 in, let me use blue. If you plug in -3, meaning wherever your x is, you plug in -3. Wherever your x is, you plug in -3, meaning my new problem, or if I plug in -3, I have 2 times -3 plus 7 minus 2 equal to -3, right? And if you see this thing here, what is 2 times -3? Well, 2 times -3 will give me -6. -6 plus 7 to give me 1. Square root of 1 is 1. Do you agree that 1 minus 2 is 1 minus 2 equal to -3? No, right? 1 minus 2 is equal to -1. And as you can see, -1 is not equal to -3. So if you plug in -3, you see that the answer does not come out correctly. And if it doesn't come out correctly, then that is not your answer. You need to have something that come out correctly one in. If you plug in the one, you should see that you will have a correct answer. How? Well, let's plug in the one. Let me erase up here. Erase this up here. So let me plug it so that you can see. If we plug in the one, and let me use the green. My original problem is square root of 2 times 1 plus minus 2 equal to 1. This is my original problem. All I did was wherever I see my x, I plug in 1. And if you look at this thing here, 2 times 1 is 2, and 2 plus 7 will give me 9. Do you agree that a square root of 9 is 3? What is 3 minus 2? Well, 3 minus 2, do you agree that 3 minus 2 is 1, and 1 is equal to 1? So that is why 1 is your answer and not negative 3. Okay, so that's what we have is after all of this mess, right? We square, we form out, we factor them out, we set it equal to 0. After all of that, this is the only answer we choosing and not this. This is not the answer. Okay. So again, like I say, the reason why I say that this is a hard problem is because they took you around the world, right? They took you every single place that we went over. They took you back, right? You have to FOIL chapter 5. You have to factor chapter 6. You have to solve chapter 2. So basically every single thing we did in this class, every single item we have is in this problem. And that's where we have here. Now, let's take a look at the next number. And I want to point out that this item is actually easier. It's easier than it look. Let's do that. Right, this is easier than it look. Even though you say, wait a minute, how can it's easier when it's a cube root, right? When it's a cube root, how can it's easier? Well, reminder, how do we solve? This is why what we ask you to do is solve as there's equal. Your problem, cube root is by itself. Doesn't matter what on the inside, my cube root is by itself. And if my cube root is by itself, life is good because now, do you agree that to get rid of the cube root, all we need to do is raise to the third power? Because like the square, the cube root and the cube power, last time a square root and a square power, they cancel out. So in this case, the cube root and the cube power, they cancel. We have 2x minus 17 on the outside equal to what is 3 or 1 times 1 times 1. Well, 1 times 1 times 1 times 1 is still just 1. And like I mentioned, why is this problem easier than the other one? Because there's no FOIL involved. And gentlemen, you will not see this. You will not see x plus 1 raised to the third power. You won't see that problem in this class. Okay, so don't worry about that. Whoever say, will we ever see a binomial x plus 4 or x minus 4 raised to the third power? For us, for this class, no, you won't see it. So to be short, you won't see that. Don't worry about it. Now, what do we do? Well, do you agree that now I is add the 17 over? And if I add the 17 over, I have 2x equal to 18 divided by 2, x is equal to 9. And you say, wait a minute, Mr. Tran, why don't we check? Well, we could check if we want to, right? If you want to check what is 2 times 9 minus 7, do you agree that 2 times 9 is 18, 18 minus 17 to give you 1? And do you agree that the cube root of 1 is equal to 1? So we check it out. We know that this answer work out. All right. So what we have in terms of solving. Question, ladies and gentlemen. I don't know if you gonna see this. If you were to see this on your homework over the weekend or your quiz over the weekend, you can see that it's actually easier than it's looked. This one here is easy. This one here is easy, and you say, wait, how can it's easy? Well, let's take a look at this thing here. And again, this is easier than G. I guarantee you it's easier than this problem here. It's easier than this problem that you have. The reason is if you look at this problem, you have a radical on one side and a radical on the other side. Again, our radical is by itself. There's no addition or subtraction outside of the radical. Now, how do you get the radical? How do you get rid of the square? Do you agree that all we need to do is I need to square on this side? And if I square on one side, I need to square on the other side. And this is why we do it, because the square and the square root, they cancel out. The square and the square root, they cancel out. Now, your new problem you have is 5x minus 3 equal to 2x plus 3. And what do we do if we have an x on both sides? Well, do you agree that I need to move my x to one side? This is what I have. The 2x and the 2 minus 2x, they cancel out. My new problem I have is 3x minus 3 equal to 3. That's a lot of 3. But please do not jump the gun. Do not say this negative and this positive, they cancel out. In order for you to get rid of the negative 3, we need to add 3. If you add 3x equal to 6, divide this by 3, your x is equal to 2. And again, you can plug into this item here. You can plug into this item here to see if you have a correct answer. If you check your answer, everybody see that all we need to do is plug in 5 times 2 minus 3. 2 is minus 10 minus 3 is square root of 7. Right? And if we plug into this, the other item is 2 times 2 plus 3. Do you agree that 2 times 2 is 4? 4 plus 3 is 7. Well, a square root of 7 and a square root of 7, they equal to each other. So we know that our answer x is equal to 2. Okay. So again, that's what we have. And if you look at this problem, don't get intimidated. You know, only get intimidated if they where you get intimidated, and this is where they have a radical. But if they do have a radical on both sides, it's actually easier than it's look. Question here, ladies and gentlemen. Now let's go to the last item, not the last. The next thing that I think that give you guys problem is rationalize the denominator. Well, let's say if they rationalize the denominator. And let's do the easy problem first, right? Let's say go back to A. The easy problem, if you have something like this, square root of 3 over square root of 17, right? Reminder, how do you rationalize the denominator? To rationalize the denominator, our objective, our goal our check denominator cannot contain the radical. So if you look at this thing here, to get rid of this radical, all we need to do is multiply the same radical, right? Because a square root of 17 times the square root of 17, everybody see that it's the same as 17 times 17. And inside we have 2. What can we bring outside? Well, we can bring 17 outside, right? And that's the idea. Is what, as long as it's a single radical and it's on the denominator, all you need to do is multiply by that. The often is if you multiply the denominator by square root of 17, you need to multiply the numerator. You need to multiply the numerator by the same number. So this is what we have, is we have a square root of 3 times square root of 17 all over square root of 17 times square root of 17. So what is 3? And this is what we have, is 3 times 17 all over 17 times 17. What is 3 times 17? Well, 3 times 17 to give you 51 on the inside. And again, 17 times 17 is, I think, like 249 or not 249. Multiply in my head. But I know that a square root of, if you look at this thing here, the 17 square, that's what we've been doing, is we say, well, if we have a square and a square root, they cancel them out, right? And that is what we have in the sense of the answer. Okay, so again, because we have a pair of the same 17 and 17, we can take out one of them, which this is my answer here. My answer is square root of 51 all over 17. Now, the only thing that we run into trouble, is, for instance, we have something like this. We have something in terms of 2 minus a radical of 5, right? We run into big trouble with this one here. It's fine. The only thing that we run into trouble is we have something like this, ladies and gentlemen, and since we added, we good. So looking at this thing here, if you compare this problem versus this problem, you can see that the main difference is the second problem, we have a addition, or in this case, we have a subtraction, right? And if we have a addition or a subtraction, in order for you to get rid of this item, we need to multiply by a conjugate. We need to multiply by the conjugate. What is the conjugate? The conjugate is whatever this item is. We use the same 2 number, but the only thing different is the sign. And if you recognize that the conjugate, and we did this earlier in the week, if you don't recognize, this is what you need to recognize, is 2 minus square root of 5 times 2 plus square root of 5. 2 times 2 will give me 4. 2 times 5 to give me 2 square root of 5. A negative 5 times 2 to give me a negative 2 square root of 5. And a negative 5 times this to give me a negative 5 times this to give me a negative 5 times 5 on the inside. And as you can see, this is the concept of the conjugate, or this is the idea, or this is the goal of the conjugate. And this is what you have left, is you have 4 minus 5. And what is 4 minus 5? Well, 4 minus 5 is give you 1. And that is the idea, is we multiply this item by the conjugate. That's what we have. And the conjugate, like I mentioned, the only thing is the number is the same. The only thing different is the sign. And if we multiply the denominator by the conjugate, we need to multiply the top by the same conjugate. Because basically this item here, if you look at it, this item is basically is 1. Because anything over itself is equal to 1. Now, what do we have? Do you agree that on the top, right? Let me combine this together. This is what we have is 4 times 2 plus square root of 5 all over 2 minus square root of 5 times 2 plus square root of 5. If you combine this together, because it's multiplication, it's basically you extend this thing here or out. And in this item, we distributive the 4 in. And if you distribute the 4 in, you have 4 times 2 is 8. 4 times square root of 5 is 4 square root of 5. Right? 4 times 2 is 8. 4 times square root of 5 is 4 square root of 5. And the bottom, we did it. The bottom, this item multiplied to this item, we did it right here. We multiply them out already. We see that this thing here eventually equal to -1. The reason earlier I say, oh, we're in trouble is, ladies and gentlemen, if you type this in your calculator, not calculator answer, or your test question, they tell you it's not in the simplest form. The only thing is because it's under 1 or is over 1, you need to take this -1 and distribute it to the whole item so that the whole thing, you need to convert to this thing here. This is your answer, because if it's over 1, anything over 1 is just itself. The only thing different now is it's over a -1, so you have to change the sign for every single item. A negative over, again, technically, if you, technically, this is what we have, ladies and gentlemen, technically, we have this. We have 8 over -1 plus 4 square root of 5 over -1. Technically, you divide it by -1, and that's why 8 divided by -1 to give you a -4. 4 square root of 5 divided by -1 to give you a negative. So that's why our answer is a -8 minus 4 square root of 5. Let's try one more and we see if you have question. Let's do they give you? Don't think they give you. Let's give you a square root of over 9. 9 plus square root of 9 plus square root of let's do 2. Let's do a little bit different. 2 square root of 3. So I know you say, ooh, this looked a little bit challenging, but it's not really challenging. Look at our goal is we need to get rid of denominator, or we need to get rid of the radical in the. And as long as the denominator, you recognize that as long as the denominator have the addition or subtraction, we need to multiply by the conjugate. So let me change the colors to make it a little bit new. What is the conjugate here? Well, the conjugate, everybody see that all is 9. 9 subtract, right? The conjugate is 9 minus 2 square root of 3. And if you do that, if you multiply the bottom by 9 minus 2 square root of 3, then you need to multiply the top by the same item. Okay, so that's our goal. No matter what they give you on the bottom, No matter what they give you on the bottom, all you need to do is if there is an addition or a subtraction, we need to multiply the conjugate. And if you do this all we got is we got a square root of 11 times 9 minus 2 square root of 3 all over 9 plus 2 square root of 3 times 9 minus 2 square root of 3. All we do is we put them together, right? And if you put them together, let's distribute the numerator. Because do you agree that a square root of 11 times 9 is 9 on the outside, square root of 11 on the inside? Minus 2 square root of 3 times 11. All we do is the outside times the outside, the inside times the inside, and this is what we have. Now, let's take a look as the denominator. If you look at this item here, we have 9 plus 2 square root of 3 minus 2 square root of 3. And if you remember what I say, we don't need to FOIL them out. You don't need to FOIL them out. All you need to do is take this number, take the first times the first, and the last times the last, you should be good. If you take 9 times 9, do you agree that 9 times 9 will give me 81? If you take this number minus, do you agree that 2 times 2 will give me 4? Square root of 3 times 3, do you agree that 3 times 3 is 9? A square root of 9 is basically 3 on the outside. And if 3 times 4, what is 3 times 4? Well, 3 times 4 is 12. Do you agree that if you subtract this, if you take 81, subtract this, that will give you 69, right? 81 minus 12, that will give you 69. So whatever the denominator is, ladies and gentlemen, the denominator, and this is what we have is the numerator. To do this thing here, the numerator, I have 9 square root of 11 minus 2. What is 3 times 11? Well, 3 times 11 is 33. 69 is my item. And looking at this thing here, you can reduce it. Looking at this item for now, just this will be my answer. You can reduce this item here by 3, but you can only reduce the first one. For now, I accept this answer. Let's say that. Let me ask you guys, question with this thing here. Question, ladies and gentlemen, how to rationalize your denominator, how to solve, how do you do your complex number? All right. Well, if you don't have question, oh, you guys been asking question? If I can see. If you don't have question, let's stop here for